All right, we are going to work on lesson 514, fraction division part 2 today. So we're going to use visual models to divide whole numbers by unit fractions. We're also going to apply and extend previous understandings of multiplication and division to multiply and divide fractions. But first, let's do our math warm-up. So it tells us, right, yes, that the product is greater than 7/8. And remember, the product simply means the answer to your multiplication problem. And no, if the product is less than 7/8. So you can see here we're starting with 7/8 and we're multiplying by 3. And if you remember, the multiplicative identity tells us any fraction or any number multiplied by 1 will simply be itself. The product will be the same as the factor you're multiplying by. Now, in this case, we have 3, which is greater than 1, so I know that my product should be greater than 7/8. I could check that by doing multiplication, but following that basic rule, we should know that. So look at the next one here, 7/8 multiplied by 2/3. So here I look at it and I say, 2/3. I know that's less than 1, and so the product's going to be less than 7/8 because I'm multiplying by a fraction less than 1. And then the last one on here, 7/8 multiplied by 1. Well, this wouldn't actually be yes or no because yes means greater than and less in this case, and no in this case means less than. So it's actually equal to, right? So in this case, you would say that 7/8 would multiplied by 1 would just be equal to 7/8. So it's not greater or less than 7/8. Let's look at another round of these. 7/8 multiplied by 1 3/4. So again, I want to do some thinking here. As I look at this, I see 1 3/4. I know that 7/8 times 1 is going to be equal to 7/8. But then I have the 3/4 on there as well. So I know it's more than 1 that I'm multiplying by. So yes, it will be greater than 7/8. The next one here, I have 7/8 multiplied by 2/2. Well, I know that 2/2 equal 1 whole, and I know any fraction multiplied by 1 is simply going to be equal to. So in this case, I would say equal. It's not yes or no. And then the last one here, 7/8 multiplied by 6/7. 6/7 is less than 1 whole, so I know that it's going to be less than the 7/8 that I started with. And then you can pause the video and work on these and see. Again, remember, look at your second factor there. See if it's less than, equal to, or greater than 1. Here, we're going to look at a story problem here with dividing fractions. So let's take some time to go through and do some cubes here and some thinking. So Jane has 2 pieces of pita bread and again, this should be 2 instead of, share with her friends. If she cuts each pita into fourths, how many pieces of pita bread will she have to share? Use your fraction circle pieces to help you solve the problem. I'm not going to use fraction circle pieces, but I'm going to use fraction bar to show you here. But first, I see 2 pieces of pita bread. I see it can be split into fourths. Okay, I see she cuts, so I know she's dividing it up. How many pieces? I also see share with. Those are all division words, right? And when I look at my question there, it says, if she cuts it up, how many pieces of into fourths, how many pieces of pita bread will she have to share? Okay, so I'm going to go first. I'm going to write out my division number model. So when I look at it, I know I'm not splitting up fourths. I'm splitting up 2 pieces of pita bread into fourths. So I'm going to say 2 divided by 1/4. And so I'm going to just draw 2 pieces of pita bread, or just 2 rectangles. And I see I got to split it into fourths, so I'm going to do 1, 2, 3 lines here. And then I got to split the second piece into fourths as well. And so when I count, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of pita bread. So you could think about this with cake or something you have at home where you might be cutting it into slices, or a block of cheese, something like that. But you can see there that when we split into fourths, we have 8 pieces of pita bread. And that looks like pita break. So let's look at the strategies we could use here. We could have used fraction circle pieces. I don't have them here on the board, so I did not use those. But you could use fraction circle pieces there. I personally like to draw rectangles. I think they're a little bit easier when doing drawings at home and you don't have fraction circle pieces. So let's look at the next one. Brian has 3 yards of string. he needs pieces of string that are ½ yard long to make pulleys in science class. If Brian uses all 3 yards of string, how many halves yard pieces would he still have? So let's see. If Brian uses all 3 yards of string, how many ½ yard pieces will he have? And so then I'm going to look, I have 3 yards, and I know I need to split them into halves. Okay, and let's see. Is there any words that indicate division? He needs pieces of string that are ½ yard long. So how many half pieces? That helps me. Also, where it says, let's see, he needs pieces of string that are ½ yard long. So ½ yard long tells me I'm going to be splitting them up. So again, I got to think about it. I'm going to write a division number model before I do my division. So 3 yards of string and ½ yard for each piece when he cuts them out. So I'm going to just draw 3 boxes because it's easier for me to visualize there. And I know I'm doing 3 divided into halves. So I'm going to split all 3 boxes in half. And when I do that, I see I have 1, 2, 3, 4, 5, 6 pieces of 1/2 yard string. I could also do the algorithm that we've looked at before to solve this. So I could say, put the whole number over 1 and then convert it to a multiplication problem. And to do that, I change to multiplication by taking the second number or fraction and flipping it, or multiplying it by the reciprocal. So when I do that, I get 6 over 1, which is simply 6 divided by 1, which is 6. So either way that you do it, you could use the illustration or the algorithm there. So some sample strategies they suggest is you could think about how many yards are in 3 yards. There are 2 ½ yards in 1 yard, so there could be 3 times 2, or 6 ½ yards in 3 yards. So that's one way you could have thought about it. You could represent 3 yards of string with a number line from 0 to 3, split each yard into ½ yard segments. You can count the number of ½ yard segments in 3 yards. There are 6, so Brian will have 6 pieces. What number model summarizes our solutions? So why does division make sense here? Well, think about if you were to physically take a piece of string and cut it in half, or a piece of paper, and you could even try this at home if you have paper or a piece of string cut. When you divide, we know we're splitting it into smaller pieces, right? Into smaller groups, so you're splitting it up. Think about in class when your teacher divides up the groups, right? At a table or for a math group. When you divide, you're making smaller groups. And so just like we talked about here, what do we notice? Well, we know that it was 3 yards divided into halves equals 6. So what do you notice about the size of the quotient? So look at this for a minute. You see here the quotient is 3. And then look at our answer. Or sorry, I said that backwards. So look at our quotient, which is 6. And then look over here at our dividend. We started at 3. And then we divided it into half and we ended up with 6. So you notice we divided 3, our dividend, by a divisor less than 1 to get a quotient of 6, which is greater than what we started with. So it's the opposite of multiplication, right? And so you got to realize that when you multiply, you're working to get larger. So when you divide a whole number or fraction by a fraction less than 1, you're getting more pieces. So your quotient will actually be greater. So the quotient of 8 is larger than the dividend 2. So let's go back to here. Why does it make sense that the quotient is larger than the dividend? So again, when you think about that with the number 8 and you're dividing by a fraction, dividing by a fraction there that is less than 1, you're getting more pieces. You're breaking into smaller groups. It can be helpful to create story context that makes sense of division problems, or like a story problem. So look at this one, 5 divided by 1/3. Why would 5 of something be split into thirds? So that seems kind of tricky, right? Because you would think of 6 being split into thirds, or 9, because those are both divisible easily by 3. But let's see. Flour usually comes in 5-pound bags. Maybe a restaurant has a 5-pound bag of flour and they use 1/3 of flour each time they make a batch of pancakes. Dividing 5 by 1/3 would tell how many batches of pancakes the restaurant can make with 5-pound bag of flour. So this is real world situations. You're not always going to get math problems or dividing a whole number by fractions where it's going to be something easy like 6 divided by 1/3 or 9 divided by 1/3 or 12. You're going to have real world situations where you're going to have to work out some of these problems, and that's where you need to have strategies to work on those. So one way to model this problem would be to draw 5 rectangles to represent 5 pounds and split each rectangle into thirds. Create number stories to represent these two problems. So this is a point where you want to pause the video, and I want you on your marker board at home or paper, or if you're here at school or wherever you're at, to go ahead and think of some story problems here. So for the first one, you would have 4 of something and you're splitting it into 6ths. And the second one, you have 3 of something and you're splitting it into 8ths. So I want you to pause and think about that. Okay, so hopefully you've had a chance to write some story problems or story context. Let's go ahead and look at a couple of these examples so you can see the general idea of what you should be looking for. Mr. Hudson bought 4 loaves of banana bread to share. If he cuts each loaf into 1/6 or 6, how many 6 loaf servings will he have? The second one there, Nina is running a 3-mile race. Race organizers put up a sign marking every 8th mile. How many signs did they put up? And again, these are real situations. If you have a big family, especially, maybe you have to split up some food there and cut it into pieces and be fair and equal to everyone. If you're a runner, you might need to keep track of the miles there, right? Or if you're someone who's helping with a race. So model and solve the number stories. Write a division number sentence to summarize each solution and write a multiplication number sentence to check your answer. So go ahead and pause the video and do that now. So you're going to take Okay, so hopefully you've had a chance to look at these two. So when I use cubes, I look at the first one, and I see 4 loaves, and I know I'm splitting it into 6. So for that one, let's go ahead and do a number model. So 4 divided by 1/6. And I'm going to draw 4 loaves of bread. Again, not the most perfect loaves of bread, but it works. I'm going to split each one into 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, when I look, I'm going to count my pieces. So each one has 6. So 6, 12, 18, 24. So I should have 24 pieces. Now, I can check that by using the algorithm. So I'm going to put my 4 over 1, and then I'm going to change it to a multiplication problem by multiplying by the reciprocal or flipping the second fraction. And I get 24 over 1, which is 24 divided by 1, which is 24. So using the algorithm and also using my model, both cases I got 24 pieces of bread for the family. All right, let's look at the next one here. Nina is running 3-mile race. And she's putting up a sign every 1/8 of a mile. So how many of those markers will she need? So again, 3 miles divided by 1/8. And so I'm going to draw 3 boxes. Again, you don't have to use boxes. You could use different shapes. I just find it easy to do those quickly. And because I have 8s, I'm going to do 7 lines to make 8s. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And again, you probably want to do a better job drawing than me to make them equal fractions. But you get the idea there. So let's see. I know that each one has 8. So 8, 16, 24. So I believe that I should have 24 markers, right, at the 1/8 of a mile. So now I can do the algorithm here to see. So I'm going to say 3 or 1 divided by 1/8. And I'm going to convert that to a multiplication problem. So I'm going to multiply by the reciprocal of the second fraction, which simply just means to flip it. And I get 24 over 1, which is just simply 24 markers. So using the algorithm and using the illustrations, either way that you go, the strategy works. Okay, so 24 there. So some sample strategies they did, pretty much what we said here. 5 divided by 1/3 is 15. How many 1/3 pounds are in 5 pounds? You could think about it that way. 3/3 equals 1 pound, so 5 times 3 or 15. Third pounds equals 5 pounds. So 15 multiplied by 1/3 equals 15 divided by 3 equals 5, and 15 is greater than 5. For the other one, you could see they did some rectangles there. Those are a little more organized and neat than mine. I was kind of doing them quickly, but you can see how they organized those and labeled each one with 6. So you could do it that way as well. I could also say 3 divided by 1/8 equals 24. I could use red fraction circle pieces to represent 3 miles. I could cover each red circle with 8 dark blue 1/8 pieces. It takes 24 dark blue pieces to cover 3 red holes. I'm assuming most of you don't have fraction circles at home, but that is a strategy that you could use. Go ahead and open your math journal to page 192. So let's look at the directions here. It's pretty long, so we want to make sure we follow all of them. For problems 1 and 2, write a number model using a letter for the unknown. So the letter for the unknown is called a variable. So you'll see that later in pre-algebra. Solve, showing your solution strategy. Summarize your work with a division number model. Check your answer using multiplication, and write a number system to show how you checked. So let's use cubes on the first one to see what we're splitting up here. How many half pounds of boxes of nuts can be made from 10 pounds of nuts? And so you can see our prompts and our questions all one thing. So are you dividing up half-pound boxes, or are you dividing up the 10 pounds? In this case, I know I'm dividing up the 10 pounds of nuts into half-pound boxes because I'm taking the large amount that I have and I'm splitting into smaller boxes or dividing. So go ahead and pause the video. I want you to complete that. Okay, hopefully you've had a chance to work on that. So let's go ahead and look at what we have here. So they did 10 divided into half-pound boxes, which equals B. So the unknown, letter for the unknown is again called a variable. So you could put B, you could put N, you could put P, any letter that you want there. Really doesn't matter. Usually try to pick one that's related to the problem, in this case boxes. You can see here they did a visual because they ask you to solve showing your solution strategy. So if you chose to do a picture, you could do that below, or you would show your math calculations there. And then your solution is simply the answer. And then your summary number model is where you take your original number model and instead of a letter, you put your actual answer. And then you can check with multiplication to see if you are correct. Okay, go ahead and pause the video. Make sure you've completed number 2 there. Okay, you should have had a chance to look at this. So let's see. It says Darcy has 6 meters of yarn. She splits them into thirds. So she is taking 6 meters and dividing them by thirds, right? So let's see what we got. See if you're matched up. So you can see they did 6 divided by 1/3. And again, they chose to use the letter P because it's related to the problem there. Again, whatever letter you want to use. You could do a visual model. In this case, they like to do the number line to jump there. Found your solution, and then your summary number model. Number 3, you're going to write your own number story. So this is just a story problem for 5 divided by fourths. So think of something that you have 5 of, and you're splitting it up into fourths. And then you're going to write your number story, and then you're going to solve your number story. And then draw a picture for your solution. And then on 4, when you divide a whole number by a fraction less than 1, the quotient is the quotient larger or smaller than a whole number. So one way I like to do when I explain these things, I like to go look at this when you do an actual number model on there. So when you divide a whole number by a fraction less than 1, so let's see, when I do like 5 divided by 2/3, I could answer that, and then I could talk about whether or not it is greater or less than. And what is the rule there? So I could also do something like 4 divided by 1/2. But any fraction where you have a whole number divided by a fraction less than 1, and you want to talk about that. Is it going to be larger or smaller for your quotient? And explain why. So that's where having a problem there can be helpful. And then you have a home links that you can practice with there.